Okay, Unit 9, Objective 5 is kind of an interesting little objective here because it serves almost as a bridge between Objectives 4 and Objective 6. Objective 4, we looked at the angle sum and difference formulas for sine, cosine, and tangent, and we can see all of those rewritten up here, the ones that we looked at and learned in Objective 4. And then Objective 6, we are going to explore more thoroughly something we started back in Objective 1, which was solving trigonometric functions, isolating the trig, figuring out what your reference angle would be and which quadrant you would be looking in and naming those angles. And in Objective 6, like I said, we're going to develop this more thoroughly by throwing in angles that are not singular angles, double angles and triple angles and that sort of thing. So in this Objective 5, because it is kind of our bridge objective, we're going to do two things with this very short set of notes. The first thing is to preface where we're headed, to preface what you're going to be looking at in Objective 6 and developing in Objective 6, as well as to develop a little bit more thoroughly what we did in Objective 4, looking at something that a type of question we are allowed to now solve given known trigonometric relationships. Okay, so there's kind of two things contained within this set of notes here. So up first, we have number 1, solve for all values of x such that x is an element of the intervals 0 to 2 pi, closed on 0, open on 2 pi. So we can include 0 as an answer. We cannot include 2 pi. And my equation is sine 2x cosine x plus cosine 2x sine x equals 1. This problem here is the one that is bridging us to Objective 6. Objective 6, again, one more time, you're going to look at it very shortly here, is where you are solving when you have more than one x inside. And so this is just, like I said, to kind of intro that idea that, again, will be developed more thoroughly shortly. How this connects to where we've come from is that what we're looking at here is something that if I wanted to solve, like I did back in Objective 1, I can't isolate any of this trigs, right? There's nothing I can factor here. There are no like terms I can combine. But what I do see is the sine, cosine, cosine, sine pattern that I have associated at this point with my sine sum and difference formula. Right? Sine, cosine, cosine, sine, sine, cosine, cosine, sine. This is the sum of two angles within a sine. And so then the question is, well, what are the two angles that are being added together here? And those two angles are 2x and x. Well, what do you know? If I actually add those, we get sine of 3x equals 1. And I've isolated my trig, which is that first step that we have to take. Back in Objective 1, we looked at this when we are solving for an angle. Once we are here, we now are able to identify our reference angle and then identify quadrant and all of that kind of thing. So the question then becomes, well, what would be my theta prime if sine had to equal 1? Right, so then you're thinking through your unit circle, what we reviewed back in Unit 8, and you're working your way through, and you're going, okay, well, for sine to be 1, that would be a quadrantal of some sort. So be thinking of some sort of quadrantal. Which quadrantal would sine equal 1 on? And sine would equal 1 here, right, 0, 1, which that angle is pi over 2. And so I'm thinking that my angle here, this 3x, has to equal pi over 2. Okay. Well, here's what prefaces where you're headed in Objective 6. In Objective 6, you are going to look and you're going to see why, and you're going to practice what this means, but you're going to look at what happens when we have more than one in here. This 3 here is showing us how many times around that unit circle we have rotated. So in this particular case, this is telling me I've gone 3 times around my unit circle. If there was a 1/2, right, if this was 1/2 x, that would tell me I've only gone halfway around my unit circle. So it communicates the number of rotations. And what that means is that while pi over 2, yes, is where sine would equal 1, because I've gone around 3 times, I actually hit that angle 3 different times, right? First time around it's called pi over 2, then pi, 3 pi over 2 pi. And then when I keep going, that second rotation after I've crossed 2 pi, what would that angle be called? Well, that angle would be called 5 pi over 2. And then I can continue around, right? You know, you've got 3 pi, 7 pi over 2, 4 pi. Now what would it be called? When we hit it, that third rotation, right? We're going 3 times around. It would be called 9 pi over 2. And what that means is if I finish solving for x here and I divide each of these by 3, pi over 2 divided by 3 is pi over 6. 5 pi over 2 divided by 3 is 5 pi over 6. 9 pi over 2 divided by 3 is 9 pi over 6, or 3 pi over 2 if you were to reduce it. And all 3 of those angles lie between 0 and 2 pi. And so all 3 of them would be included in our answer. We can see this graphically if we were to graph sine of 3x, like we learned how to do back in Unit 8. Right, if we graphed this sine of 3x here, my HK would be at 0, 0. I'll write this, y equals sine of 3x. My HK would be at 0, 0. My amplitude would be 1, so I'd be going up 1 and down 1. And my period would be 2 pi over my b, which is 2 pi over 3, because my b is 3. And so we'll call this pi over 3, so 2 pi over 3 would be there. And that would be 1 period of my sine. But if I wanted to go all the way to 2 pi, that right there is just at 2 pi over 3. I could do it again to hit 4 pi over 3, and one more time to hit 6 pi over 3, or 2 pi. So I could actually get in 3 iterations of this sine function as I get to 2 pi, which is why, like I said, this 3 indicates how many rotations we have. And we equal 1 at 3 different locations, right? That equals 1 over here at 3 different locations, 1, 2, 3. Okay? Like I said earlier, this is going to be something that gets developed very shortly here in Objective 6, and you're going to see other examples and you're going to practice this. But what we're doing here with Objective 5 is simply saying that these sum and difference formulas that we learned in Objective 4, they could be used in the context of any of the things we learn this unit, right? I could use these in a proof. I could use these for solving. We're going to, in a bit here, learn actually a new problem, which is kind of more the focus of Objective 5. But I could use sum and difference formulas on that problem. So the sum and difference formulas become almost kind of like the identities that we've already been using in earlier objectives, like the Pythagorean identities. Sine squared plus cosine squared equals 1, or your reciprocal identities. You know, cosecant equals 1 over sine, or things like that, right? So we need to make sure we understand that these 3 here can now be used in, sorry, these 3, 1, 2, 3, can now be used in the context of any of the problems we have learned and will continue to learn and practice as we walk through the rest of this unit. Okay? Okay, and again, like I said, you're going to see more of this shortly in Objective 6. Objective 5, the real focus of Objective 5 is learning this type of problem right here. It's what you see in numbers 2 and 3. These problems, you are given a couple of facts about an angle or potentially more than one angle. And your goal is to then answer whatever questions accompany those facts. And you're going to continue to see this type of problem in several other objectives of this unit. This is like everything else in this unit. This is not going anywhere, right? We're still going to continue to use this idea. This is just where we're first learning it here. Okay? So we've got some steps for this type of problem when you're given these facts and then asked to determine some other quantities. Step 1, we recommend drawing two triangles, one for alpha, one for beta. Obviously, if you're only given alpha, you only draw the one triangle. But if you are given multiple angles like this, draw one triangle for each of them in the appropriate quadrant. And we'll talk shortly about how you know which quadrant they're supposed to be in. You then want to fill in any missing sides, so that would require Pythagorean theorem potentially if you don't know your Pythagorean triples. And then make sure to include direction signs, positive or negative. We want to make sure that we are accurately reflecting those coordinate points. That would get me into that quadrant. Okay? Step 2, after you've done that, you're then going to expand whatever statement they are asking you to evaluate. You're going to expand and then substitute in. Be sure to replace the entire trig statement with the ratio. What we mean by that is simply this. Every once in a while, I will see students who have, cosine alpha, and maybe they know that cosine alpha equals, we'll say 5/13. Well, if we know, which is what this one equaled. So we'll go ahead and say cosine alpha equals 5/13. And then they're in the midst of their problem and they get to the place where they're wanting to plug into cosine alpha, and rather than substituting 5/13 into cosine alpha, which is what we want to do, that's what cosine alpha equals, I'll see them write this, cosine of 5/13. All right, well, the entire cosine alpha equals 5/13, not just alpha, right? We don't want to do this. Make sure you're substituting in for the entire trig statement. Okay, so here we go. This is what this looks like. We're going to go ahead and do part A and part B of number 2. Number 2 says, given that cosine alpha equals 5/13 and tangent beta equals -3/4, alpha is in quadrant 1 and beta is in quadrant 4. Okay, so before doing anything else, we're going to go ahead and draw those triangles, right? I'm going to go ahead and leave myself some workspace here. So first up, we've got our alpha triangle here. Even before reading this last statement, ladies and gentlemen, cosine alpha is 5/13. Since cosine is positive, we actually already know that it's in one of two quadrants, right? What quadrant is cosine going to be positive in? Okay, well, cosine's positive in the first or fourth, right? So we should already have that in our mind even before we read what's at the end. Right? I should know up front that I'm going to be drawing my triangle here in either the first or the fourth quadrant because cosine is positive. And then I get back here and they tell me alpha is in quadrant 1. Perfect. Right? I knew it had to be in either quadrant 1 or quadrant 4. I'll go ahead and draw my triangle in here. Here's my alpha. Cosine is adjacent over hypotenuse. So my adjacent is 5. My hypotenuse is 13. This missing side then, you either know your Pythagorean triple or you are doing Pythagorean theorem. One of the two. So to solve for that missing side using Pythagorean theorem, you'd get 12. Or you could do your Pythagorean triple, 5, 12, 13, and you'd know it was 12 that way. Both of these are going to be positive because to get into my first quadrant, it would be a positive x and a positive y to get me to that coordinate point, right? Positive x, positive y would put me here. The hypotenuse, just for the record, will always be positive. It's these sides that might be negative if I was wanting to move left and or down. Okay, so that's triangle 1. Triangle 2, we also know something about beta. So they tell me tangent beta is -3/4. So again, even before reading the end, we should already know if tangent is negative, beta is in one of two quadrants. Where is tangent negative? Okay, well, tangent is negative in the second and fourth quadrant, right? All students take calculus, so it's either the second or fourth. So even before reading the end, I should already be thinking my beta triangle will be going either the second or fourth quadrant. And then we get to the end, it says beta is in quadrant 4. Perfect. Go ahead and draw our beta triangle here. Tangent is, right, SOHCAHTOA, so tangent is opposite over adjacent. So opposite would be the 3, adjacent would be the 4, and then this is negative, so we know there needs to be a negative in there somewhere. Which one would be negative to get me to go right and down like that? Right is positive, down is negative. That's where it says make sure to include direction signs. So you want to make sure your sides here reflect how we would get to this coordinate point at the tip of my triangle. And then you're either using Pythagorean theorem to calculate that side, or you know your Pythagorean triple, which is 3, 4, 5. And again, hypotenuse will always be positive. And you've got your two triangles. What those triangles allow us to do in part A here is to now take our expression and expand it. Okay, well, sine alpha plus beta, this is the sine sum formula. So we're going to go ahead and go sine first angle, which is alpha, cosine second angle, which is beta. Same sign, right? Sine is same, so this would be plus. And then cosine alpha, sine beta. This is again using our sum and difference formulas that we learned in Objective 4. Okay. And now that we have it expanded, we can substitute in, because sine alpha, I know. They didn't give me sine alpha, but I have the alpha triangle, which is in the first quadrant. Everything's positive in the first quadrant. And sine alpha, opposite over hypotenuse, would be 12 over 13. Oops, 12. That should be a 12 there, sorry. 12 over 13. Cosine beta. They didn't give me cosine beta, but I've got beta's triangle. It's in the fourth quadrant, so cosine will be positive. Adjacent over hypotenuse would be 4 over 5. Cosine alpha, first quadrant, everything's positive in the first quadrant. So cosine adjacent over hypotenuse would be 5 over 13. And sine beta, fourth quadrant for beta, sine is negative in the fourth quadrant, so opposite over hypotenuse would be negative 3/5. And so then multiplying these, 12 times 4 is 48, 13 times 5 is 65, 5 times negative 3 is negative 15, 13 times 5 is 65, and 48 plus negative 15, or 48 minus 15, is 33. Okay. Which then brings us to part B. At this point in the unit, there are kind of two questions that they're going to ask us. One is to evaluate one of the trigs. Could be sine, could be cosine, could be tangent. But they might have asked us to evaluate a trig. The other question they could ask you is, what quadrant does that angle, in this case alpha plus beta, lie in? Okay? Well, in order to answer this second question, we need two trigs. It doesn't actually matter which two trigs you use. In my recommendation would be you've already found sine of alpha plus beta. So I would recommend finding either cosine or tangent and using sine as one of them, right? Because again, you need two different ones. Whether you use cosine or tangent doesn't matter. Personally, I always like using sine and cosine when I get the choice. I don't really like using tangent unless I have to, just because it's a more complicated formula. And since it doesn't matter which two I use, I can use either one. The reason that we have to use a second trig is because since sine of alpha plus beta is positive, I know that alpha plus beta lies in one of two quadrants. Where would sine be positive? Well, sine is positive in the first or second quadrant, but without knowing what cosine or tangent would be, I don't know whether it's the first or second. I know alpha plus beta is in one of those two, because sine is positive, sine of alpha plus beta is positive, but I don't know which one it is. And so I'm going to go ahead and find, again, it doesn't matter, but I'm going to find cosine of alpha plus beta. And depending on whether cosine is positive or negative, that will help me determine whether I'm in the first or second quadrant. Okay? So let's go ahead and do this. So we've got cosine alpha plus beta, which is cosine first angle, cosine second angle, cosine changes, so this would be minus sine first angle, sine second angle. Plugging in cosine alpha, here we're at 5/13. Cosine beta, 4/5. minus sine alpha, 12/13, sine beta, -3/5, which is 5 times 4 is 20, 13 times 5 is 65, minus 12 times -3 is -36, so minus a negative would be positive. 13 times 5 is 65, and 12 plus 36 is 56, which is positive. Well, there is only one quadrant where both sine is positive and cosine is positive. What quadrant is both sine and cosine positive in? And that would be quadrant 1. So therefore, our alpha plus beta angle here is in quadrant 1, since both sine of alpha plus beta and cosine of alpha plus beta are positive. Again, as you continue through this unit, you will look at some other questions that also could be asked, like these two, but at this point we're going to work with these two. And again, this is really objective 5 right here. Okay, so number 3, my recommendation is, now that we've done number 2, pause the video, try number 3 on your own, restart it either when you've got an answer or are stuck, or if you'd prefer, just get a step ahead. But if I start to move too fast, then pause the video to give you a chance to actually get a step ahead. You need to figure out, where is your question in this process? Where are you getting stuck? So that you can advocate for yourself. And you're not going to be able to determine that if you don't try it on your own. Okay? So pause the video if you're going to do so, or get a step ahead. Okay. Given sine of alpha equals -5/13 and cosine of beta equals 3/5, and neither alpha nor beta are in quadrant 4, find sine of alpha plus beta, and what quadrant is alpha plus beta in? Okay, so here we go. Let's break this down. So sine of alpha equals a negative. What quadrant does that mean alpha, or what quadrants, there are more than one, but what quadrants could alpha be in if sine is negative? Okay, well, sine is negative in the 3rd or 4th quadrant. So we know we're going to be in either the 3rd or 4th quadrant for alpha here. At the end it says neither alpha nor beta is in quadrant 4. So if I can't be in quadrant 4, but I have to be in the 3rd or 4th quadrant, then that means alpha is in the 3rd. Okay, opposite over hypotenuse. Then using either the Pythagorean theorem or your Pythagorean triples, we would know that this missing side was 12. Now careful, to get to this coordinate point, I would need to move left and then down. So if I needed to move left, what does that mean about this 12? Okay, it should be negative, right? Which is why, for the record, both cosine and sine are negative in the 3rd quadrant. Okay, beta. Cosine beta is 3/5. So if cosine is positive, what quadrants does that mean I might be in? It would be the 1st or the 4th, right? That's where cosine is positive. But neither angle is in quadrant 4, so what quadrant does that mean I'm actually in? Quadrant 1. So here's my beta triangle. Cosine adjacent over hypotenuse. Adjacent would be 3, hypotenuse would be 5. Using either Pythagorean theorem or Pythagorean triples, that side would be 4. And I've got my beta triangle. Okay. Now that we have those, we can go ahead and solve our problem. So A is up first. We're going to go ahead and find sine of alpha plus beta. So let's go ahead and expand it. Sine alpha cosine beta plus cosine alpha sine beta. And now we can plug in our terms. Sine of alpha would be -5/13. Cosine beta is 3/5. Cosine alpha is negative 12/13. And sine beta is 4/5. Negative 5 times 3 is negative 15. 13 times 5 is 65. Negative 12 times 4 is negative 48. 13 times 5 is 65. And negative 15 plus negative 48 is negative 63. Oops, that should be 5, sorry. And we've got our answer. B then, what quadrant is alpha plus beta in? Well, I know sine of alpha plus beta was negative, which tells me that alpha plus beta is in one of two quadrants. What quadrants would alpha plus beta have to be in for sine to be negative? Okay, well that should be the third or fourth. But which one it's in requires another trig, either cosine or tangent. And again, doesn't matter. I'm going to do cosine. So let's go ahead and take a moment and expand that. Cosine alpha, cosine beta, minus sine alpha, sine beta. Cosine alpha, here's alpha, cosine would be negative 12/13. Cosine beta would be 3/5. Sine alpha, negative 5/13. Sine beta, 4/5, which is negative 36/65 minus negative 20/65, which is negative 16/65. Well, there is only one quadrant where both sine is negative and cosine is negative. What quadrant is both sine negative and cosine negative? That would be quadrant 3. So therefore, alpha plus beta is in quadrant 3, since both sine of alpha plus beta and cosine of alpha plus beta are negative. Okay, and so that is objective 5.